What's up, Minecraft gamers? Mr. Cully coming at you with another lab, and this one is our Stoichiometry Lab. This is our intro to Stoichiometry Lab, and we are going to be working with a couple different substances. Now, let me explain first our setup, and then I'll talk about the lab itself. But here we just have a normal scale. The scale goes to 0.00, the hundredths place, in grams, and we have a Bunsen burner. We got a ring stand, which is basically this apparatus, and then we have this wire gauze for our flask to sit on. We also have two different chemicals. So the first chemical that we have is sodium bicarbonate. This is just a fancy name for baking soda. So you can see it's just normal baking soda. Sodium bicarbonate is NaHCO3. And then we also have sodium carbonate. All right, so it's very, very similar. It sounds similar. It's not bicarbonate, but it's carbonate. And you can see that their chemical formulas are slightly different. It's Na2CO3. And that just looks like a white powder itself as well, but this one is used for more so washing. It's a laundry booster, whereas baking soda, we can use that in cooking as well as freshening up things and things like that. But they're similar, but they're also different. So we're going to be using both of these, and we also have hydrochloric acid. So hydrochloric acid is just an acid. It's got the formula HCl, and this is 3 molars, so it's kind of concentrated. And we just have some measured out amounts of that. So here's our setup. Here's our goal for this experiment. Well, I give you these two very specific amounts of each of these substances. And I'm going to ask you to tell me what the masses of each of these are without you actually using this thing. It's like, well, Cully, how do I do that? And the answer is stoichiometry. So here's what I'm going to have you do, all right? Or at least have you watch. First step that we're going to do is, since we're using this flask, all right, we are going to take the mass of this flask. That's the first thing we're going to write down. So the mass of this flask is 70.8. 70.8 grams. That is our mass of the empty flask, okay? And you'll see why that's important here later on. But the first one we're going to do, we're going to do an experiment with this sodium bicarbonate, all right? We're going to take this powder and put it in the flask, just like that. Okay, make sure you get all of it. And we are going to react this powder with the hydrochloric acid. So it's just 8 milliliters of hydrochloric acid, and you're going to see that this experiment looks pretty much like the one with vinegar and baking soda. You're going to see it foam up just like that. And what you're seeing is carbon dioxide getting released. So what happens when you mix sodium bicarbonate with an acid, or any acid with a base, you get a reaction that produces carbon dioxide, which are the bubbles, water, and salt. And in this case, our salt is just sodium chloride. So after this reaction, what's left here is pretty much just salt water. That's all that is. There might be a little acid left over, but there's no baking soda, and we just have salt water here. So what we're going to do is we're going to put our mixture there on the ring stand, center this Bunsen burner underneath, turn on the gas. We're going to light this thing. There we go. So we're going to wait for this thing to evaporate. We want to evaporate all that water out so that we just have salt left behind. So if you want to skip over this part, you totally can, but I think it's kind of cool to watch. By the way, this is shot on an Android. Yeah, that's what I thought. You can see the salt crystallizing on the edge of the glass like that. All right, just about all of that is now crystallized. We don't have any water left in there. So Now that it's dry, we can go ahead and turn the gas off. And this is gonna be super hot. So we're gonna give that a second. While that's happening, I'm gonna go over here. Here's my desk for all of you who have never been in my room. And we're going to get our lab so that you guys can follow along. And we are doing part 1. Okay. So I hate waiting, so we're gonna speed this up a little bit. Just gonna take it. Go and put that over here. Let me zoom out. There we go. All right, and now we're getting a mass of 71.24 grams. All right, so now we have 71.24 grams. All right, what does that mean? Well, that means if you take the difference between these, remember this was the empty flask, and this is now the flask with the salt in it. Okay, that's the salt. If you take the difference between these, you should get the mass of just the salt. So what's 71.24 minus 70.8? That should be 0.44, okay, grams of salt. So for experiment 1, what we're doing, we just got 0.44 grams of salt. All right, so that's for experiment 1. All right, let's go ahead and take this off now. Set that aside, and I'm going to go ahead and get a new flask because that one's going to be too hot to put under the water and it's probably going to crack. So we'll get a different one. Isn't this great? You get to actually see what I do. All right, this one's fine. It's a little bit smaller, but that's fine. And we're going to take the weight of this one as well. And I'll write that down on a separate one. So we have here the mass of this one is 39.70, so 39.70 grams. All right, and we're going to be doing the same thing we did before, except now we're going to be using the washing soda or the sodium carbonate. So here we go. You can see that these are not as fine as baking soda is. It's more like salt. It's got the texture and the coarseness of salt, but it's not salt. All right, so we got that. And again, we're going to do the exact same thing. We're going to react this with the hydrochloric acid. You see all the carbon dioxide coming out. All right. We'll add some more for good measure. All right. Swirl that around, make sure it's all reacted. Android. Yeah. Try doing that on an iPhone. Yeah. There we go. All right. We're going to do the exact same thing. Light this. This one actually should be a little bit quicker. All right, now that's just about done. Turn off the gas there. Let that cool for a second. All right. Watch I drop it. I would still post this anyway. All right. Put that there. Find the new mass is 40.2. Okay, so we got 40 point. Oh, look at me trying to write. 40.20 grams. All right. So this one's pretty simple too. You just find the difference to find the amount of salt that's left, and this one's going to be, looks like exactly 0.5 grams. All right. So we're going to take that, move that over here. All right, so what can we do with these values? We just found the amount of salt produced from each of these reactions. Well, now comes the stoichiometry. So we're going to transfer these numbers, and we're going to put it into a stoichiometry problem. So I kind of already laid it out here for you. So we're going to take, this was experiment 1 now, we're going to take that value from experiment 1, which was our 0.44 grams, and we're going to put that here, 0.44 grams. All right. And now your job is to get from this amount of grams all the way back to the grams of the sodium bicarbonate that I gave you. Remember the one that I didn't tell you how much it weighed. And so you're going to get a value here. You're going to get a value. After you do all this math, you're going to get a value. And what you're going to do is you're going to compare that to the actual value. So the actual value here that I gave was 0.80 grams. Okay. So whatever answer you get here compared to the actual value that I gave, and you're going to find percent error using this equation. All right. So you just follow the equation and see it's the absolute value of the actual mass, which is this number, minus the experimental mass, which is the number you get here, divided by the actual mass, which is this number, times 100. That'll give you your percent error. So you're going to see how far off were you from the actual value. Down here, you're doing the exact same thing. So the actual mass, or actually let me go back. This is experiment 2. So 0.50 grams, that's what goes here, 0.50 grams. And the actual mass for this one was 0.70 grams. Okay, and you're doing the exact same thing. You're going to compare whatever value you get there with this value and do percent error and calculate that. All right, well, how do you go about doing stoichiometry though? Well, for this one, you got to find the molar mass of NaCl, and I'll do this one for you. The molar mass of NaCl, sodium chloride, is 58.5 grams. Okay, should be a point there for every 1 mole. All right, and down here is the mole ratio. So now you have to go back and look at that equation. So we did this in class during the pre-lab, and we found that everything has a 1-to-1 mole ratio in this equation. So we don't have to change anything there. And then lastly, we need to get from moles of sodium bicarbonate to grams of sodium bicarbonate. So you need to figure out what the molar mass of this is. And I believe, I could be wrong, is 84. So every 1 mole of sodium bicarbonate is 84 grams. And you're going to get some number here for your grams of sodium bicarbonate. And that's what you're going to compare to that value. And that's what you're going to plug in to this equation to find your percent error. And you're going to do the exact same thing for this down below. But keep in mind, your mole ratio for this is going to be different than your mole ratio for this. You have to look at the coefficients for each equation to get that mole ratio. So for this one, it's a different mole ratio than it was up here, the 1-to-1. You have to look at the mole ratio. You have to look at the coefficients from the second equation that we did in class. All right. Let me know if you have questions.